All right, guys, so the Unit 4 test is trig and more factoring. So what do we have here? Two triangles. You're going to use a different trig function for each. So remember, and we'll make sure to have this on the board too, but the shortcut to remember is sorry for the handwriting, SOHCAHTOA. Okay. Short for the sine is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse, and the ratio for the tangent is the same as the slope angle, is the opposite over the adjacent. Sorry guys, my puppy's being weird. So what do we have here? So here's the 90-degree angle in this triangle, which means that the one directly across from it, I'll highlight it in yellow, is the hypotenuse. And on the triangle below it, if that's the 90-degree angle here, then the side directly across from it is the hypotenuse. The hypotenuse is the only side that does not touch the right angle. And then you've got to be careful. You've got to look at what we're given, because it's the opposite and the adjacent sides are going to be different depending on which angle you're given. So if we're looking at angle 64 degrees right here, we have the hypotenuse, right? We have the hypotenuse for both of them. And here, this x, let's do that, let's highlight that in another color. The x actually touches, that side actually touches that same angle. If it touches that angle, that's the adjacent. So I have the hypotenuse and the adjacent. So this first one is going to be the cosine of 64 degrees is equal to the adjacent, the x, over the hypotenuse, which is 25. And in the triangle below, I'm given the side that does not touch the angle. It's directly opposite the angle, so that's going to be the sine. So this one down here is going to be the sine of 50 degrees is equal to, and this time my variable is going to be on the denominator, 12 over y, because y is the hypotenuse. Y, the yellow one is the hypotenuse in both of them. Okay, so it's going to make it a lot easier. The first one is a lot easier because it's a one-step process. The variable's on the numerator. This really means x divided by 25, so the inverse is to multiply both sides by 25. That cancels out 25 on this side. And then when you're doing this, wait to put the cosine of 64 in until the very end, or else you end up with some rounding errors. So we're going to have x is equal to, and then the math I have to do is just 25 times the cosine of 64. So I will do, how did I get into matrix mode? 25 times the cosine of 64 is 9.7. And now let me double check and make sure that I am in degree mode. And nope, I'm in radian. So look, I have to go over to degree. Then I'll go back to the main screen. I'll do the same exact entry. 10.96. If I round correctly, it's going to be 10.96. That's to the hundredth spot, dollars and cents. The reason why in the second triangle that it's a two-step process is because first I have to bring that y up to the numerator, so I multiply both sides by y just like I had multiplied both sides by 25 before. But it ends up being a two-step process because now I have y times the sine of I'm still in the first problem, the sine of 50 is equal to 12, okay? The inverse of multiplication, of course, is division. So to get y by itself, I have to multiply both sides by the sine of 50. And then, because it'll cancel out over here, it'll just be 1. My answer will be 12 divided by the sine, Arnold, of 50. And approximately 15.66. And this time, look where I'm pointing on the calculator. Here's the number I need, and then I have to look at the next number. It's a 4, so it's less than 5, so it's just going to stay 15.66 to the hundredths place. Okay, and I guess both of these should technically be approximately, since I did round them to the hundredths place. All right, what's next? Draw an equilateral triangle. All sides are 8 inches long, and an equilateral triangle, all sides are the same. Okay, so 8, 8, 8. What is the height so the other thing about equilateral triangles is if we know that all of the sides are the same, all of the angles are the same. So if we have 180, I know those angles need to add up to be 180, and I split 180 up into 3 equal pieces. I divide it by 3, I get 60. So each angle is actually 60 degrees also. I'm looking for the height, so you draw the height straight down. That breaks up the bottom into 2 equal pieces of 4. So there's 2 different ways to do this. I'll show you how to set it up both ways, but I'll solve the Pythagorean theorem way. If this is 4 and this is 8, and I need this here, a lot of people are just putting 4. It's not 4. Don't just put 4. But I do know that 8 is the hypotenuse, and the hypotenuse is C. I'll call 4 A, and I don't know what B is. So I have A squared plus B squared equals C squared. So 4 squared, A is 4. I don't know what B is. I keep that B squared. C is 8, so 8 squared. 4 squared is actually 16, and 8 squared is actually 64. So 16, 64. So subtract 16 from both sides, and you get B squared is equal to 48. Okay, what does this mean? B squared is the same as B times B. I'm looking for some number. When I multiply it by itself, I get 48. So in order to do that, what you do is you take the square root of both sides. That's the inverse operation of squaring something as the square root. So B is equal to, normally it would be plus or minus the square root of 48, but whenever we're doing Pythagorean theorem, it's always positive. And the square root of 48 is 6.9, and I'm going to say 3 because the number after the 2 is 8, so approximately 6.93. Or we know that angle is 60. I know I have the hypotenuse and the adjacent. You could set it up as the cosine, and you get the same exact thing. Check it. The cosine of 60 is B over 8. If you just multiply both sides by 8, you get your answer. All right, for number 3, it helps to draw it. A street slopes at an angle of 15 degrees. There's 15 degrees. There's the bottom of the hill that we don't see. Okay, and it becomes a right angle. If we go over a horizontal distance of 120, so that makes us 120, it says how far does it rise? So we're looking for this right here. We'll call that x. So I don't have the hypotenuse, right? And the only trig function that doesn't use the hypotenuse is the tangent. The tangent of 15 degrees is the opposite, which is x, over the adjacent, which is 120. So we multiply both sides by 120. One-step process. It's much nicer when the number's on the denominator. Cancels out. So tan 15 times 120. Approximately 32.15. 32.15. All right. Okay, for the diagram at the right, YA is parallel to AT. That's wrong. It's IA is parallel to NT. I hope you guys kind of guessed that. It's my fault. Or the book's fault. Make a flowchart or claims and evidence to show the triangles are similar. So because these are similar triangles, they share this angle and these are parallel, it means that these two, and you can make your own flowchart, I'll just tell you why. These two angles are the same because they are the same. They are, oh man, you guys are going to make me forget it. I'll tell you later, but you know what I mean. It's on the board. They're the same angle. So the end property that finally shows that they are similar is angle, angle. And since they are similar, what else do we know? We know that this and this are the same, which is both 6, which means for the big triangle, it's 12. So from here to here is 12. This is 6. And that makes it really easy to find out what x is because it's really easy to find the scale factor, because if the small one is 6 and the big one is 12, that's a scale factor of times 2. So if I'm looking at these corresponding angles, thank you. If I'm looking at these corresponding sides And I know that the smaller one is half the size of the bigger one, then x must be 14 because of that scale factor. Okay. Diana is a new student. He does not explain what you do in complete sentences. You can do that. I'll show you what to do, but you just need to explain how you do it. And then the question on Schoology asks you for some coefficients. So here, this is going to be to find this little rectangle, we need both of these sides, right? We know this side's -1, and we know this side up here is the same as the bottom side, which is 0.5y. So on the inside is -0.5y. It's -1 times 0.5 is -0.5. We have our y. And then for this one side is 3, one side is 24x. So that ends up 3 times 4 is 72x. Okay, so you're multiplying the sides of that square to get the insides of that square. Factor each of these completely. Let me do that in a separate video. And then right now I'll just answer this last one. So the hint here that I put on in the computer is, or in Schoology anyway, is that the two sides of the two smaller sides of a triangle must add up to be more than the third side, the longest side of the triangle. So in this first one, 5 plus 6 is 11, and 11 is greater than 9, so this one could be a triangle. Number 2, I think this is a 4, you guys, could be a 1. Either way, it doesn't work because 4 plus 8 is 12, but it's not bigger. It's equal to 12, but it's not bigger than 12. It's got to be bigger. And this last one, 7 and 8 is 16, and that's definitely not bigger than 17, so your answer is A, 1 only.